Good evening, everyone. My name is Tatiana Jenkins, and this is the Introduction to Data Mining Take-Home Midterm taught by Professor Chin. Once again, my name is Tatiana Jenkins. So the instruction for the take-home midterm was to implement hybrid clustering, which consisted of K-means clustering and hierarchical clustering to form an algorithm that will express certain data based upon what you set for yourselves in this coding, and you will see what I did with mine in my presentation. So what is clustering? Clustering is a task that sets objects together in groups based off their similarities. These clusters can be done in more than one way to express things that are in groups. So the differences can be shown ultimately in your results based upon colors, shapes, sizes, and different graphs, which you'll also see further in this presentation that I implemented for my hybrid clustering. If you think about clustering realistically, if you want to be on campus about it, you can do clusters based off of things that people are involved in, their titles on campus, their ethnicities, and things like that. So hierarchical clustering. Hierarchical clustering is a more organized way to cluster because it's always in a predetermined order. We were taught two different ways, which was divisive from top to bottom that it can be classified, or agglomerative, which is from bottom to top. A real world example that I used was a family tree, which started at the top. It starts with your grandparents or your great grandparents, however further you want to go. If you even think about ancestry.com, then it goes further down to the parents, to the children, and if those children have children, and then some. K-means clustering. K-means clustering is kind of more of an unorganized way to group data. This algorithm ultimately has to be repeated until the data objects find each other, basically, until the iterates and centroids become one, if we're being politically correct. So as you see in the graph on the left-hand side here, before K-means, the data objects are close enough to see the difference and where they'll begin to separate ultimately from one another by 3. Then after the K-means, as stated before, when it comes to implementing data sets in this algorithm, it could be labeled by different colors. So the green, the red, and the blue all exemplify different clusters that were created. So let me show you guys my code here for how I got my graph that you just saw. I'm going to run this one more time. So in my hybrid algorithm that I created a maximum of 3 so to exemplify the cluster that I wanted to see, and I used a color threshold to show my results. So in green here is one cluster, in this bluish purplish color is another cluster, and in red is another cluster. As stated, I created a loop. My loop ultimately went almost 6 times to get the common ground for my iterates and centroids to become 1. And this is the graph that was shown. Now to strictly implement the K-means clustering, I used the V measure. Here you could see my code here, but it's really been acting funny all day and not letting me run it on MATLAB. But this was supposed to create the Excel sheet kind of that we've all seen throughout the class to give me to max out my clusters, which is giving me my my labels for each class and category for my data implemented. But here's a skim of the code so I don't take up too much time trying to run it. And here are my results one more time, and I thank you all for your time.